Before we get into talking about a new kind of power index, let's talk about some of the details of weighted voting. So we talked about some of the basics in the previous video, and let's go over those basics right now. So here's an example of a weighted voting system contained in these brackets. The first number is always the quota. That's how many yes votes you need to get the yes motion to pass, or how many no votes you need to get the no motion to pass. And then you list in descending order all the weights of the players. So in this case, the player 1 has 8 votes, but player 4 only has 4 votes. Okay, now let's look at some of the special cases that are going to cause us problems in weighted voting. The first is called Anarchy and is represented by this voting system right here. So let's say this is the case. We have player 1 and player 4 vote yes on some motion. That means as a total of 8 and 4, that's 12 yes votes, which is enough to cause the yes motion to pass. But wait, what also happened is that player 2 and 3 voted no on this motion, and 6 and 6 make 12. So that's 12 no votes, which means that the no motion should pass. In fact, this is not a good weighted voting system at all, because it allows for both the yes motion to pass and the no motion to pass, which brings us no closer to our final goal of finding a final result. For that reason, this is called Anarchy. And when is this going to happen? This is when the quota is set less than or equal to V over 2. And the problem with that is because if it's less than or equal to half the number of votes, that means that there's enough votes to cause a yes quota, cause the quota to give a yes vote, and also enough to cause the quota to tell us that we have a no vote. So in that case, we have Anarchy. So keep this in mind. And the next thing we'll talk about is Gridlock. Gridlock is kind of the opposite situation, where we don't have enough votes to get a yes or no. In that case, look at this. The quota is 12, but what's the total amount of votes we have? 4, 5, 6, 7, 8, 9, 10. So if everybody votes yes, that's 10 votes, which is not enough to meet the quota. If everybody votes no, that's 10 votes in the opposite direction, which is still not enough to meet the quota, which means that no decisions can ever be made in the system. There'll never be a way to make a decision using the system. This is called gridlock because it kind of locks us in place. We can't go anywhere. And when does this happen? This is when the quota is too high, when it's greater than the number of votes there are total. So using these two examples, we don't want Anarchy because we want a single decision, not two, and we don't want Gridlock because we want to be able to find a decision in the end. So what do we make sure of? We make sure that both these conditions are not true. We do not want this and we don't want this. So Q should be greater than V over 2. Q should be greater than V over 2. And what should also be true? It should be less than or equal to V. Less than or equal to V. So as long as Q is in this range, we'll be able to make a decision using the votes that using the weighted voting system that we have. So Q should be less than or equal to total number of votes, but greater than total number of votes divided by 2. Okay? So now let's talk about a few more things. There's such things as deceptive systems. This weighted voting system is fair. Let's make sure it's fair. What's the total number of votes? 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay? Is 12 less than or equal to 12? Because 12 is the quota, and it's true. So since Q lies in this range, then we're good. This is a fine weighted voting system. But notice something. Notice that how do you get a yes or a no vote to pass in here? What if the three strongest members of this weighted voting system all vote yes? That's 4, 5, 6, 7, 8, 9, 10 votes. That's still not enough to get up to the quota. You need this last member to get up to the quota. What if these 3 people vote no? That's still not enough to get to the quota. You need this last person to also vote no to get up to the quota. In fact, there's no winning coalition, remember that word, winning coalition, except everybody. So the only winning coalition would be player 1, player 2, player 3, and player 4. All together. There's no other way to get a winning coalition. For that reason, everybody has the same say in this weighted voting system. And this can be deceptive because you see people have different amount of votes, but everybody has the same exact say. Because if one person's not on board, then it doesn't work. Even if this person's not on board, it doesn't work. Everybody has equal representation, even if these numbers might say otherwise. That means this weighted voting system is equivalent to this one. 4, that's the quota, and then everybody has 1 vote, because just like in this voting system, in this one, if you take out anybody, the motion will not pass. So really, everybody has equal representation, which is deceptive, because you might think this person has the most power. If we do the Bonzaf method, we'll find that everybody has the same amount of power, 25%. The next thing to talk about is a dictatorship. This is where one person has a lot of power, and we'll define what a lot of power means. So the quota here is 12, and we see something weird already. This first person has 13 votes. This next person has 5, this next person has 6. So if this person with 13 votes says yes, if he says yes to the vote, then it's going to pass. He single-handedly can be his own winning coalition. Now, what if he says no? If he says no, then if these other 2 people say yes, that's 6 and 5, which is 11, which is not enough to get this to pass. For that reason, this person is a dictator, because he completely controls the vote. These people have no power whatsoever. Whether they say yes or no, the actual decision is controlled by this person, the dictator. And for that reason, these people are called dummies. So to reiterate, the dictator is someone who completely controls the weighted voting system. He controls whether it's going to be a yes vote or a no vote in the end. Dummies are people who are basically not dictators, people who have no say in the system at all. So for that reason, this system right here is equivalent to this one. The quota is 1. This dictator has 1 vote and everybody else has 0. In this one, it's much easier to see that this is a dictatorship because it all comes down to whether this person wants to put his vote in or not. Then he'll decide how the decision is made. So we can talk a little bit more on dummies. In this case, it might have been easy for you to see that this person was a dictator and these people were dummies, because these people have so much less votes than this person here. But we can also have dummies with someone who has almost as many votes as everybody else. In this system, there is no dictator because no one person controls the entire share of the weighted voting system. But we do have a dummy, and that's going to be player 4. And how do we prove he's a dummy? Well, to prove anyone's a dummy, you need to just answer these 2 simple questions. So if the vote is currently a yes, can player 4 make it a no? So if player 4 is currently saying yes to it, which means that pretend it's the coalition that's winning is player 1, player 2, player 3, player 4. Pretend everybody voted yes. Can player 4 make it a no by dropping out? Well, if he drops out, it's still going to be player 1, 2, and 3, which is going to be 30, which is enough to meet the quota. So he makes no difference. If it's a yes, it's going to stay a yes. And notice that if you want a yes vote in this system, if you want the quota to be met, you need all 3 of these first guys, because if you don't have one of them, then the maximum you can get is 29, which is not enough. So if it's a yes vote, it's going to be everybody. And by dropping out, player 4 makes no difference. So right here we say that nope, makes no difference. Now we answer the second question. If it's a no vote, can player 4 make it a yes by joining in? So let's pretend we have a no vote. Let's say we have just player 1 and player 2. That's no, right? Because if we have 10 and 10, that makes 20. So that's not enough to make our quota. So can player 4 make it a yes? Well, if he joins in, then he's only going to make it go up to 29, which is not enough. So again, he makes no difference. So pretty surprisingly, player 4 is actually a dummy in this case, because his vote makes no difference whether he's in it or he's not. Now let's look at the last thing, veto power. Veto power is somebody who's not a dictator, but he's kind of close, because this player 1, let's say he's not on board. He does not vote yes. How much is the power of the rest of the people? 4, 5, 6, 7, 8, which is not enough to meet our quota of 12. So that means if player 1 has preventive power, or veto power we can call it, which means that if he's not on board, he can make it a no. So he can't make it a yes, but he can make it a no. So let's formally define this. Let's say V is the number of voters, Q is the quota. Any player with veto power has a weight. Let's say his weight is W. His weight has to be less than Q, because if it's greater than Q, then he's a dictator, which we're saying he's not. So his weight has to be less than Q. But what else do we know about his weight right here? Well, we also know that if we have the number of votes in the weighted voting system and we subtract his weight, then that's not enough to meet the quota. That's less than the quota. So if we just rearrange this a little bit, we're going to get the inequality right here. We're going to get W is greater than V minus Q. So these 2 conditions together define someone who has veto power. So this is just some of the things that can happen in weighted voting systems that can cause them to kind of break or fail. So we just want to be careful to analyze them completely, calculate the Bonds-Off power index, make sure that we're not dealing with any of these deceptive systems.